Good morning. I hope you guys are adjusting well to this new change. I'm going to go ahead and spend this video going over Chapter 10, Section 5 from your textbook. So for those of you who are able to log onto your textbooks, you can go to Chapter 10, Chapter 10, Section 5 for additional support. And then at any point, you can pause, rewind, or rewatch this video to kind of help you out. So what's a tangent? A tangent's going to be a line or segment, ray, whatever, that intersects a circle in exactly one point. So right here, R would be our point of tangency because segment RS is intersecting that circle in exactly one spot. The other thing to know is that that point R would be the point of tangency, and then two, that tangent line, segment, or ray will always be perpendicular to the radius. From the point of tangency to the radius, that segment, so this segment here, is always going to be perpendicular to the tangent. So in just kind of identifying here, we have two circles that are intersecting. I only get two tangent lines. There are only two lines that exist that I'll be able to get points of tangency. And then in the example B, where we have our two circles are separated from each other, here we end up having a total of 4 common tangents. And so that's going to be a ray, line, or segment that one of these lines, rays or segments, will have 1 point of tangency on each circle. So here, if I look at this line, I get a point of tangency and a point of tangency. And you see another one here, point of tangency, point of tangency. We have another, and then the one similar to the first example where we have the point of tangency across the tops of the circles, and then another one down across the bottoms of the circles. So those lines can only touch in one spot. Give this one a try. Good job. So in this example, we see that AB is tangent to circle C. So we have AB's tangent, and then what I forgot to put in here is that BC is perpendicular to AB. And so I went ahead and drew in my indication there, my symbol. And so this one is really nice because we get that right triangle. I know you guys' favorite. And then we can use that knowing two sides solve for x by using Pythagorean theorem. Now, before we jump into Pythagorean theorem, I want to remind you, BC is a radius, which means DC, because it's going from the edge of the circle to the center of the circle, it's also a radius. So it also has a length of 9/8. So if I just kind of zero in on the triangle that's been drawn, AB has a length of 8, BC has a length of, AB is x, BC has a length of 8 units, and then AC is going to be 9 plus the 8, giving us that value of 17. And so x is going to be equal to 17 squared minus 8 squared. So I'll give us a moment to go ahead and calculate that. All right, and we get x has a value of 15 units. So here we have more fun with our tangents, circles, and of course these triangles. In the first example, we are looking here for the value of x, and I see x is representing the hypotenuse of triangle JHK, and I do have my legs of 15 and 20, which means it's Pythagorean theorem. X is going to equal the square root of 20 squared plus 15 squared. And so this gives us x has a value of 25. And then if I take a real quick look here at the next one, same thing, we're looking to find the value of the hypotenuse. So I'll give you a moment to try that one on your own. Go ahead and pause. All right, good job if you got that 29.411. And if you didn't, that's okay. Take a look at your equation, look how you set up, and make the adjustments that you need. If you're getting restless, we're almost done. We're about halfway through. Okay, so in this next part, we're now talking about if two segments from the same exterior point, so that's going to be like point S. So if that point S is tangent to a circle, then that means that these two segments will therefore also be congruent. So if RS and ST are tangents, notice how we can see they're sharing that same point S. Then we know that segment RS is going to be congruent to segment ST. Whoops. All right, so here we're looking for the value of x. Real quick, tell me, what is the value of x for circle M and A? All right, good job. I knew you guys could do that. All right, those last two problems were way too easy. You guys are pre-AP. So let's kick it up a notch. And now we're going to talk about the circumscribed polygons. And so this is where we have a circle embedded inside some sort of polygon. And notice when that happens, every single spot, there's going to be a point of tangency. Every single spot is a point of tangency. And because of that, that tells me since point G is as tangent, it's sharing this segment and this segment, they're the same distance, so they're going to be congruent. Hold up. This segment here will be congruent to this segment. Same thing, segment. All these little pieces are going to be congruent because of the definition that they're coming, these 2 points are tangent and they're using that same exterior point. All right, so here, I'm not looking for just the value of x here. I want to know what is the perimeter. So take a moment and first of all, find the value of x for this question here over on the left. And then find the perimeter. Don't assume it's a circle. Remember, no TBL. All right, for the image on the left, if you got x has a value of 4, you are correct. And the reason why is not because we TBL'd, is because this piece right here has a value of 8, which means 2x is congruent to the 8. They're equal. And then, so 8 equals 2x, divide both sides by 2, and we get x has that value of 4. And so if this is 8 and this is 8, the whole thing is 16. This is 8. This whole thing is 16. And so, yes, we can now safely say it is a square. And then the perimeter would be 16 times 4, which gives us the value of 64 units. Whatever these units are, I'm really bad at not including those units, but we need to change that because you guys need to be able to put those units when you're taking your AP exam. All right, now we can look at the triangle. I know you guys were so eager to save the best for last. We have the circles inside a triangle, and it's the same rules here. If this segment is 13, then I know this segment over here is 13 because they have that same exterior point. Down